Hi everyone, welcome to MyMax Academy. In this video, we'll continue with the chapter relations and functions, which is chapter 1 from your 12th standard CBSE mathematics. We will continue with example 12 in page number 8 in your textbook. Page number 8, example 7. Example 7. Page number 8, example 7. It says let A be the set of all 50 students of class 10th in your school. So what is A set? So given is, and given condition here. So given is the set A is set of all 50 students. 50 students in class 50 students of class 10th standard, class 10th in a school. In a school, set of all 50 students of class 10th, that is our A set, and F is a function defined from set A, which is set of all students. So A set has set of 50 students of class 10th in a school. A to n, A to set n, we call it as dilation, which is set of all natural numbers, such that f of x is defined as roll number of a student f, roll number of a student x. If x is the name of the student, then f of x will denote the roll number of that student, right? So we have to show that f is 1 to 1 but onto. So what we have to prove? So to prove is f is 1 to 1, right? And second is we should prove f is not onto. F is not onto. You have to show that f is a 1 to 1 function and f is a not onto function. Now the solution or proof, right? The solution is, again, so the function f is from A to n, and A is set of all 50 students of class 10 in a school. So if you want to visualize how this function will look like, I'm just drawing this arrow diagram to represent the function. You don't have to draw this diagram every time, but if you are confused, then it's better to, whenever you feel like you are not clear with the function or anything, then it's better to draw this diagram. But I'm drawing for your understanding. So f is a function, and this is your set A and this is your set n. So n will have numbers 1, 2, 3, 4 instead of all natural numbers. It goes till whatever, infinite set. And A will have set of 50 students are there. So it's the name of the student. The student, suppose student is Anita, is one student. Then suppose say Azar is another student. Say Babu, another student. Say Chitra, another student. Say Joseph is another student, right? David. So like that, there are many students. I'm not listing all. Suppose there are some 50 students. They are in 10th standard. So how it is? Suppose we are the mapping between the set A and set n. N is set of all natural numbers. This set n is set of all natural numbers. Natural numbers are represented with stylish n. Right? Suppose the function is such a way that f of x is Anita. F of Anita denotes the roll number of the student Anita. So suppose if I assign Anita to roll number 1, suppose Azar to roll number 2, Babu to roll number 3, say Chitra to roll number 4, right? Suppose I'll have it as David, right? So David is the Gayatri. So David to roll number 5, Gayatri to roll number 6, and so on and so forth. So which means we are mapping every student to a number. To what number we are assigning the roll numbers to them. So roll number of Babu is what? 3. Roll number of Chitra is what? 5 or 4. Chitra goes to 4. Roll number of David is what? 5. So this is how the mapping is. Now we should prove that this is 1 to 1. And clearly this function is 1 to 1 because what is the definition of 1 to 1 function? 1 to 1 function means, right? A function is 1 to 1. 1 to 1 function means the images of distinct elements of x under f, under the function f are distinct, right? If f is a function from, suppose f is a function from set x to set y, then the images of distinct element of x under f are distinct. That is the definition of our 1 to 1 function, which you can see in your definition that is given in your book, right? So which means the images of two distinct elements of x. So this is your x set, this is your y set. Generally this is from x to y. So here it is from a to n. A is the domain, n is the codomain. Here x is the domain, y is the codomain. Then two distinct elements, which means two different students will have different roll number, distinct roll numbers, right? So two students cannot have the same roll number. Two students cannot have the same roll number. So which means Anita and Azhar both cannot go to 1 or both cannot go to 2. Then it becomes many to 1 function, right? So we'll say clearly f is 1 to 1 because two or because no two different, we can say, or we can even say clearly f is 1 to 1 because the roll numbers are different for different students. Right? If there are two different students, they will have two different roll numbers. They cannot have the same roll number. Two students cannot have the same roll number. We will say clearly f is 1 to 1 because the roll numbers are different for different students. Roll numbers are different for different students, which means no students can have the same roll number. So therefore f is 1 to 1. Now we should prove f is onto. We have to prove that f is onto, which means what is definition of onto? Definition of onto is for every element in y, the codomain, we should find an element x such that f of x should be equal to y. Right? Every element in this set should have an x such that f of that element should be equal to y. Right? Every element here should be image of some element here. Every element here should be an image of some element in the domain set here. So which means now if you see this A set has only 50 students and this N set has infinitely many numbers, which means I can take one number which cannot be a roll number of any of the students here, which means you can always find a number in the codomain such that there is no student who will have that roll number because this is only 50. So even maximum if I am going in the sequence order, suppose 1, 2, 3, if I am assigning the roll number as 1 to 50, right? So 1 to Anita, Azhar is 2 like that. So all the 50 students will go to first 50 numbers, 1 to 50. If I have the number 51 is the roll number, we have 52, 53, 54 many numbers. Suppose if I take 51 from this set N, there is no student whose roll number will be 51 because all the 50 students are mapped from roll number 1 to roll number 50, which means we have many numbers 51, 52, 53, so on and so forth. Those numbers do not have any student whose roll number is that. Clear? So we will say, we can assume the roll numbers of 50 students we can assume the roll numbers of 50 students to be from numbers 1 to 50 in n, 1 to 50 in n, then 51 is a number. 51 belongs to n. 51 belongs to n. The number 51 is here. Suppose if this is 51. There are many numbers, 50 to 53, many numbers are there. So till 50 it will be mapped to all the different students. But 51 there is no, even 52 does not have any student whose roll number is 52. So we can take any one number, which is, let's take 51. 51 belongs to n, but there is no student in A. There is no student in set A. A means set A, such that there is no student in A, such that his or her roll number is 51. So which means for the number 51 we cannot find any student here whose roll number is 51, because the 50 students are assigned to the numbers 1 to 50. So all the students are given roll numbers, but still we have many numbers left over here, because this is an infinite set. It has many numbers. Even I can say number 52 is there. There is no student whose roll number is 52. We can take any one number. Even if we can find one number from this set which does not have an x, x denotes the name of the student, x here, such that f of x should be 51. So if I say f of Anita, if you see f of Anita is 1. That's how it is defined. F of x equal to the roll number of the student x. So f of x means f of Anita. So these are x, small x, and these are called as small y. Right? The elements in the codomain are denoted by small y. The elements in domain set A are denoted by small x. So for f of Anita is 1. That we call it as f of x is equal to y. So y is 1. X is Anita. Then again another x, Azar. F of Azar is 2. F of Babu is 3. So we can say f of Chitra is 4. Like that. Right? So such that his or her roll number is 51. Therefore f is not onto. F is not a onto function. Clear? So all of you can pause the video and take the notes. We have proved f is 1 to 1, right? Oh, I should say here f is 1 to 1. We have proved clearly f is 1 to 1, and also we have showed f is not onto. So all of you can pause the video and take the notes here. Yeah, go to the next problem, which is example 8. What is example 8? So example 8, what is given is, show that the function f from n to n. So the function is from given example 8. Example 8 is given as f is a function from n to n. F is a function from set of natural numbers to set of natural numbers. Right? N to n, and defined by such that f of x is equal to 2x. And what we have to show, again we have to show that first we have to show that f is 1 to 1, and then we have to show f is not onto. F is not onto. We have to show that f is 1 to 1, then we have to show f is not onto. Now how do we show that? F is 1 to 1 and f is not onto. Now let's try to understand again the function, how it is. So this is your I'm drawing the arrow diagram. So this is your n, this is also your n. Fine. So both are natural numbers. So this is like 1, 2, 3, 4, 5, 6, dot 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 dot. It goes on. This is also 1, 2, 3, 4, 5, 6, dot 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 dot. Fine. Now how this function is? Now if I find f of 1, 1 is getting mapped to what? So these are your x, these are your y's, right? And the function is f. Now how it goes? So 1 goes to, suppose if I put, this is your x, if I put first x as 1, 2 into 1 is 2, your f of x is y actually. Your f of x is your y. This is called as f of x, right? So 1, if I put x is equal to 1, 1 into 2 is 2, so 1 is mapped to 2. And if I put x is equal to 2, 2 into 2, 4, so this goes to 4. Again if I put 3, 3 goes to 6. If I put 4, 4 will go to 8, 7, 8. Right? So similarly 5 will go to 10. 5 will go to 10. 6 will go to 12. And so on and so forth. Now we have to prove that this is 1 to 1, but it is not onto. Right? So you need not draw this arrow diagram. You need not represent this function in an arrow diagram like this. But I have drawn this so that you understand how the mapping happens. 1 goes to 2. How we are saying 1? Because put 1 x is equal to 1 here. Then I get 2 into 1 2. So f of x is 2. This is my f of x. These are x. These are the corresponding function values of x. So 2 will go to 2 2s are 4, 3 will go to 2 3s are 6, 4 will go to 2 4s are 8. Then put x is equal to 5, 2 5s are 10. So that's how the mapping is. Now we should show that f is 1 to 1 but not onto. But again 1 to 1, if you look at it, it looks like everything goes to only one element. So two different numbers is not going to the same number, right? But generally how we can write the proof for 1 to 1 is always, we will say that the meaning of this mathematically, what it means is if f of x1 equal to f of x2, which means if the image is same, f of x1 is called as image, f of x2 is also an image. If f of x1 equal to f of x2, then we should show that x1 equal to x2. The numbers are also equal, we should show. If the images are equal, we should say that corresponding numbers are also equal. Right? So whenever we have to prove, we should prove that if f of x1 equal to f of x2, we have to show that that implies x1 equal to x2. So if we could prove this, we have to start with this and we have to prove this. We have to start with f of x1 equal to f of x2, where x1 and x2 are the numbers coming from here. Whenever they have same image, suppose two numbers, they have the same image, which means then we need to prove that those two are not different numbers, they are one and the same number. Right? One and the same number. Suppose here if it is 2, right? If it is 2, 2 goes to 1 is getting mapped to 2, right? So f of x1 equal to f of x2 means I can say f of 1, right? How we can start this? The explanation for this one is 2 equal to 2, which is this 2, and 2 is what? F of 1. And this 2 can only be written as f of 1 only. It can't be written as f of anything. So 2 is equal to 2, which means 2 is what? F of 1. F of 1 is 2, which means 2 I can write as f of 1. F of 1 equal to f of 1, which means 1 equal to 1. This is x1, this is x2. 1 equal to 1. Which means it's not x1 and x2 are two different numbers, it is one and the same. So whenever the image is same, we have to show that the number itself is same. Then it is 1 to 1. So we will follow the same logic for almost all the proof. Wherever you need to prove f is 1 to 1. Now for that, so we'll always start with this. So proof for 1 to 1. So 1 to 1 is, proof for this is, we'll say let x1 comma x2, we are taking two numbers from this n domain belongs to set of all natural numbers, that is domain. Domain, we are taking from domain. This is called as domain, this is called as codomain. The first set is always domain, second is codomain. Such that f of x1 equal to f of x2. So we have taken two numbers x1 and x2 from this domain set. We have taken two numbers such that their images are same. They have the same image. Then we should prove that no, the number itself is same. It's not x1 and x2 are no different. X1 will be equal to x2. X1 is equal to x2. That we have to prove now. We have to prove x1 equal to x2. Now what is f of x1? What is the definition of f of x? F of x is 2x. And f of x1 will be 2x1. Equal to what is f of x2? 2x2. So in the place of x, we have to put x2. Because this is f of x2. In the place of x here, we have to put x2. Right now 2 will get cancelled. We'll get x1 equal to x2. So when the images are same, f of x1 is an image, f of x2 is an image. If the images of two numbers are same, right, then we have to show that the number itself is same. The number itself is same. If the numbers are different, suppose x1 and x2 are different, which means two different elements have same image. When two different elements have the same image, then it becomes many to one. It becomes many to one function, or it is not a one to one function. So for all the proof for one to one, we will take the image is same. Suppose image of two numbers are same, then we should show that the number itself is same, which means the numbers are not different. The number itself is same. The numbers are not different. Suppose the numbers are different, then it will become not one to one, because two different numbers. If x1 is not equal to x2, then x1 x2 are two different numbers. Then two different numbers, they have the same image. F of x1 is equal to f of x2. F of x1 is the image of x1, f of x2 is the image of x2. So two different numbers will have same image, means it becomes not one to one. So we will say, suppose the image is same for two numbers, then we should show that the two numbers are itself same. They are not different. You should prove that the two numbers are same. If you prove that the two numbers are same, then it becomes one to one. If you get x1 is not equal to x2, then it becomes not one to one. If you get x1 is not equal to x2, then you get it's not one to one. If you get x1 equal to x2, then it is one to one. So therefore, we started with f of x1 equal to f of x2, and then we got x1 equal to, we proved x1 equal to x2. We started with this, and we got this. So therefore, f is one to one function. Now we should prove that f is not onto. We have to prove that f is not onto. Now clearly what we observe here. So if you see, for every element there is an image, fine, but to prove that it is not onto, we have to prove that it is not onto, which means we should find at least one element from here which is not an image of anything. I should be able to find one. Suppose we take 3 or 1. No element here is getting mapped to 1. Therefore, it is not onto. Right? No element from this set is getting mapped to 1 here. Similarly, 3. So none of the odd numbers will have any element in this, such that the image is these odd numbers. So none of the odd numbers is an image of any number here. So we can just take one number. So we will say we'll take one number. We'll say 1 belongs to, we can even say 3 belongs to. We can say 3 belongs. So 3 belongs to n. 3 belongs to n. This is codomain. Codomain. 3 belongs to n bracket codomain. Because if I just say write n and without mentioning domain or codomain, then we may get confused which n we are talking about. Because the set is the function is from the same set to itself. So n is, so if I take an element from codomain, 3 belongs to n, which is codomain, but there does not exist any x belonging to n. Here this n is x comes from domain, such that f of x equal to 3. There is no x such that f of x is 3 means x is getting mapped to 3. F of x equal to 3 means x is getting mapped to 3. That does not. I said there does not exist. Not is very important, right? 3 belonging to n. So I took an element from the codomain, but I'm not able to find any x here, such that f of x is 3, which means that number is getting mapped to 3. F of x is 3. So 3 belongs to n, but there does not exist any x in n, which is domain, such that f of x should be equal to 3. So I'm not able to find any x here, such that f of x should be 3, which means that number is getting mapped to 3. So no number here is getting mapped to 3. See, even for 5 there is nothing getting mapped to 5. Even for 1 there is nothing getting. So you can even say 1 belongs to n, codomain, but there does not exist any x in n, which is domain, such that f of x is 1. We can also say that. So if you can find one element here which does not have any x, such that the number that this number is an image of some number in x. If you are not able to find any x like that, then we can say it is not onto. Even if you find one element which is not an image of any of this element here, then it is not onto. So therefore we'll say, so therefore f is not onto function. Onto means onto function. F is 1 to 1 means 1 to 1 function. Even if you don't mention function, it is understood. It is understood. Fine. So that's how we proved that f is 1 to 1, but f is not onto. Fine. So all of you can pause the video and take the notes. Yeah, I'll go to the next one, which is example 9. So example 9. So what is given in example 9? So example 9 is given as f is a function from R to R. So here R is set of all real numbers, stylish R to stylish R. Set of all real numbers to set of all real numbers given by f of x is same function as the previous problem, 2x. We have to show that f is 1 to 1, and we also should show that f is onto. We should also show that f is onto. We have to show that it is 1 to 1 and onto. If a function is 1 to 1 and onto, it is also called as a bijective function. Right? Now, so in this case, it will become, we have to show that it will become 1 to 1, and here also it will become onto. Now 1 to 1 is what? The same proof. Though I erased it, we should take two elements. So let x1 comma x2 belongs to R. Now here the same thing. Right? Here how the set will look like is, so this will be R, and this will also be R, set of all real numbers, stylish R. Right? So it will have 1, 2, 3, minus 1, 0, all this root 2, because it is all 1.2, all the 1 by 3, all numbers, all real numbers. This is also all 1, 2, 3, minus 1, minus 2, this will also have minus 2, all numbers, all the real numbers, root 2, 1, minus 1.2, 3.5, 6.27, all numbers, 1 by 2, 1 by 3, all numbers, dot, 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 dot. Many numbers are there. Clear? So set of all real numbers is of set of all real numbers. Now how this function is f of x? If I put 1, then 1 will go to 2. So this number 1 gets mapped to 2. 2 will go to 4. So 4 is also here. So 2 goes to 4. 3 goes to 6. Minus 1 will go to minus 2. If I put minus 1, that will go to minus 2. So every number, right? Root 2 will go to 2 root 2. 2 root 2 is also here. That is also a real number. 1.2 will go to 2.4. 1 by 3 will go to 2 by 3. Because 1 by 3, if I put 1 by 3, 2 into 1 by 3 is 2 by 3. So all these elements, 0 will go to 0. 0 is also here. 0 will go to 0. Fine. Minus 2 will go to minus 4. Right? Minus 2 will go to minus 4. Minus 4 is somewhere there. Suppose it is here. Minus 4. This is how the mapping is. Now, we should show that it is 1 to 1. Now, let x1 comma x2 belongs to R. R is obviously these are x, x1, x2, x3, these are y, and y is f of x. These are y's, these are x. Now I'm taking two x1, x2, two numbers from R, which is domain. If I say x, it is understood that we are taking from domain. If it is y, it is coming from codomain. Such that f of x1 equal to f of x2. Now what we should prove? We should prove x1 equal to x2. Then it will become 1 to 1. Now what is f of x1? Same as before, 2x1. What is f of x2? Put in the place of x2. In the place of x, put x2. So 2x2. No, 2x, you get x1 equal to x2. So we started with f of x1 equal to f of x2. We proved this. So when the images are same, the number itself is same. The number itself is same. Therefore, it is, so these are called as pre-image. So when the images are same, we'll say the pre-images are also same. Right? These are called as pre-images. These are called as images. These numbers are called as images. These are called as pre-images. So when the image is same, the pre-image itself is same. When for the same image, if you have different pre-image, the pre-images are different, then it is not 1 to 1. So therefore, we'll say f is 1 to 1. We can also write 1 hyphen 1. Instead of saying 1 ONE hyphen ONE, we can also say 1 to 1. So the f is, sometimes I may write like this. If I write like that, then please understand that it is 1 to 1. So f is 1 to 1. We have proved. Now we have to prove that f is on to also. So in the earlier case, for the same function, f was not on to, because the function was from set of all natural numbers to set of all natural numbers. But here it is from set of all real numbers to set of all real numbers. So what makes a difference is, for example, see, for 3, same number, if I take, suppose 3, if I take number 3, which number will be mapped to 3 from here? Which number will be mapped to 3 is 3 by 2. 3 by 2 is also here. All numbers are here. So 3 by 2 will go to 3. 3 by 2 will go to 3, because if I find f, what is f of 3 by 2? Is 2 into x. X is 3 by 2. 2 into 3 by 2, which is 3. So if I take 3, my x is 3 by 2. If 3 is my y, my x is what? 3 by 2. 3, then it is 3 by 2. If I take 1, then it will be 1 by 2. Right? If I take 5 here, it will be 5 by 2. 5 by 2 will be mapped to 5. Fine. So any number that I take, half of that number will be the x. So which means every number you take from here. Suppose if it is 1.2, which number will go to 1.2 from here? 0.6. Because 0.6 will go to 1.2. Because 2 into 0.6 is 1.2. So any number that I take from here, I have a pre-image. I can always find the next step. Then that will make it onto, because the definition of onto is what? For every y, for every y belonging to y, there exists at least one x, or there exists at least x belonging to x, such that my f of x should be equal to the small y. So if I take any small y from this set y, so generally we call this as x to y. Function is from x to y. If I take any element from y, then I should be able to find an x in this set x, such that f of x is y. Because y becomes the image of x. So for every image, we'll be able to find an x. Image is y. X is pre-image. So for every image, we can find a pre-image. That makes it onto. So here, so which means for every element, we are able to find what? That is half of that element. Right? So suppose, so how do we write the proof for this is? Proof is, mostly we'll write the definition of onto. We'll say for every y belonging to y, this one R. Don't say y, capital Y. Don't put a capital Y like this, because for this, if f is a function from x to y, then it is capital Y. But here x is a function from R to R. So x is R, y is also R. So for every y belonging to R, codomain. So I'm taking from this right side set, which is codomain. Right? For every y belonging to R codomain, there exists x equal to, now we need to find that x, how that x should be, because for every number, so if I take 3, the corresponding number is 3 by 2. If I take 5, it is 5 by 2. So whatever number I take, it is half of this number, that will be my x. If I take any number here, half of this number will be my x. Right, half of the number only, if I substitute here, the 2 into x will give me the same number. So for every number, if I want to take 0.2, half of 0.2 is what? 0.6. So 0.6, put 0.6 here, I'll get 1.2. So every number here, right? If I want to find for 3, it is 3 by 2, which means if I want to find for y, it will be y by 2. For every number, for every y belonging to R, there exists x. X should be how? X should look like what? X should be, how do I find that x is? We should put this f of x equal to y. Do this in the rough work. Don't show it in the main work. Do this as a rough work. F of x is y. What is f of x? 2x. So 2x is equal to y. From this find x. X becomes y by 2. X becomes y by 2. So for every y belonging to R, there exists x is equal to y by 2. X is equal to y by 2. So how do we get x is equal to y by 2? By putting f of x is equal to y, and f of x is what? 2x. You have to substitute and write x in terms of y. In the rough work you do this. Don't show it in the main work. In the rough work you can do like this, and then you can find the x. So for every y belonging to R, there exists an x equal to y by 2, and this will also belong to R. That x should be in R. See, in the earlier case also for 3 by 2 will go to 3 in the earlier case. But 3 by 2 was not, in the earlier case, it was from natural numbers to natural number. 3 by 2 was not part of natural number, and 3 by 2 is not a natural number. But that is why in the earlier problem, when this was n to n, we said 3 did not have any x here, because the x was 3 by 2, but 3 by 2 is not a natural number. If right, so because 3, any number which maps to getting mapped to 3 as per this function is 3 by 2, but 3 by 2 is not a natural number. So in the earlier case, we said it was not onto, but in this case 3 by 2, it is from R to R. If 3 means 3 by 2, it is there in this set. So we should, for every y in R, which is codomain, there exists an x belonging, which is equal to y by 2 belonging to R, which is, that R is what? Domain. Because we have to show that x belongs to R. X is also a real number. X will be a real number because y is a real number. Y belongs to R means real number. So y by 2 is also a real number. Right? If y is a real number, y by 2 is also a real number. Half of any real number is a real number. So therefore x is equal to y by 2 belongs to R. Such that we have to find what is f of x. What is f of x? Don't write y. We have to prove that f of x is equal to y. Such that f of x is equal to f of, what is x? X is y by 2. Y by 2. That is equal to, now what is f of y by 2? F of x is 2x. F of y by 2 means 2 into, in the place of x, I have to put y by 2. So 2 into y by 2. The place of x, I have to put y by 2, then I will get what? 2 will get cancelled, I get y. So such that f of x is equal to y. So we have got this. For every y, there exists x in x, which is the domain, such that f of x should be equal to y. We have proved that f of x such that f of x is equal to y. Now how to get this x, that x is equal to this x will give you f of x is equal to y. How do I know that x is equal to y by 2? Because you have to put this, do the reverse of this. Put f of x is equal to y, then write x in terms of. For every problem you have to do this. And once you get that x is equal to y by 2, and make sure that this y by 2 is also, this y by 2 is present in this set. And y by 2 will be present in this set because it is a real numbers. Y is a real number means half of the real number is also a real number. So it will be there. Right? See, y is here. But y by 2 is also a real number. That we take it as x. So that will also be here. That will be in the domain. Which means x is y by 2, y is a real number. So y by 2 is also a real number. So if I take my x in such a way that x is y by 2, then f of x will be equal to y. Which means every image, its pre-image will be y by 2. And don't think, sir, y is here means y by 2 also should be here. No. Y is here, right? It's in the domain. Y by 2 is also here, but it is also here because y by 2 is a real number. Y by 2 is in both the places. But we have to show that y by 2 is here also. Whether it is here or not, we don't care. Y is here, that is important, but y by 2 should be here. Yeah, y by 2 is here because y is a real number means y by 2 is also a real number, and real number is this is a real number. So for every y in this R, which is the codomain, there exists an x in the domain such that f of x is equal to y. Therefore, f is onto. Therefore, f is onto function. So we have proved f is 1 to 1 and we have proved f is onto. So all of you please pause the video and take the notes. And I will stop here. You please watch my next video for the continuation of this. Thank you for watching.